we're starting 4.3 rotation. We need to go to page 172 in the book. And we need to, there are 3 definitions we need to get done. We need to get done rotation. We need to get done center of rotation and angle of rotation. Okay, as you're writing this down, a rotation is a transformation in which the figure is turned about a fixed point. That fixed point is called the center of rotation. Rays drawn from the center of rotation to a point and its image form the angle of rotation. Okay, those are really complicated ways to say that basically we're going to have a point, and your shape might be some distance away from said point, and we are going to spin it like a spinner, right? Okay, our center of rotation for our purposes is always going to be the origin. The angle of rotation, we're going to keep them fairly basic. They could technically be any angle. We're going to keep them basically 90-degree turns. So we're going to basically do 90 degrees, 180 degrees, and 270 degrees. Something you need to know about math. And so I'm about to write you some formulas here. But in math, we always go counterclockwise. And so I almost find this out of date that we call it counterclockwise. Because, most of the time we just don't have real clocks. But counterclockwise looks like this. I also call it NASCAR because what do you do in NASCAR?
You go left.
You go left. And so if it's, so you can think about you go left, you can think about NASCAR. So, we're in the United States, we do that. But math is always clockwise, but a lot of people think well, why do we go against the clock? Why doesn't the clock go the same way that we do math? Math came first. But, here's some things to help you remember. When we learned like this right here, this coordinate graph here, way back in the day we learned that this was 1, this was quadrant 2, this was quadrant 3, and this was quadrant 4, right? Remember doing that, yes? So, see, it kind of goes clockwise, right? When you get into Algebra 3, Honors Algebra 3, you're going to learn a different style of graphing, which is going to be basically circle graphing. And you also are going to go counterclockwise. So just get used to everything is counterclockwise, NASCAR style, or taking a left turn. And so these formulas will be that way. So to do 90 degrees counterclockwise, we are going to take this and transform it. And if you haven't figured out, when you use an arrow, that means you're transforming it. Okay, and I'm going to make sure I'm right. To make sure I'm right, you can always look at this on 173. I like to use these formulas on this. It is hard to visualize this and do it the right way. Some people can do it. Some shapes are harder than others, but it is easier to just use the formulas. or the patterns to get it done. You can visually check it, but sometimes it even doesn't pass the visual check, where it's like, this doesn't look right, but it is. All right. Of course, what it means when I put the B and the A, it means I'm going to switch the order, right? And then, of course, B turns negative. And we're going to practice this with a point just to make sure we can do that. We'll pick a good point. 5, 6. Let's go ahead and try to see what 5, 6 would look like. 90, 180, 270. How come I don't do 360? I'd end up back in the same spot, right? And so that might be impressive to do a 360 with like a snowboard or skateboard, but it's not that impressive when you're graphing because you just basically trace over your original object. So 90, 80, 70. In real life, you could do some other things. We're not so worried about that at this point. We're just worried about the basics here. And I'll show you how I would do if it wasn't at the origin in a little bit. You're just going to have to do the origin. All right. 90, 180, 270. Great. 5, 6. What am I supposed to do here? Well, I'm supposed to switch the order. 6, 5. And which one am I supposed to make negative? Is that right? Okay, what do I do here? Just make them both negative? And what about here? Is that it? Okay. This particular chapter, you do get a single cheat sheet. This would be good cheat sheet material to me, right? So I'm just saying that might be something you want to work on before the test. Okay. So that's basically that. There's not much more to this. This is a rigid motion. That means the shape is not going to change size or shape. So here's what we're going to do, and we'll see if I can show you the stuff. Okay, this is going to be mainly a graphing day. So just be ready to do lots of graphing. And you guys are going to have more time than other people might, so that's, I guess, good. So we're looking at 176. You might as well turn your book to 176 so you can see what we're supposed to do. All right, so it looks to me like I'm supposed to draw this shape, and it says graph the polygon and its image. That's the pre-image. So its image is just going to be rotated 90 degrees. So I'm just going to take like this point right here. This point is maybe what? Negative 3, 1, 2. So negative 3, 2. And then I'm going to use my little formula and switch the order. So instead of negative 3, 2, let's go back here. So instead of negative 3, 2, which is the image, I'm going to switch the order for 90 degrees. So that would be 2, negative 3. And I'm supposed to change the B to negative. So that's the point I would graph. Does that make sense? All right. So we're going to do a bunch of those, like 4. And then we're going to get down to basically the whole purpose of this. We're going to and this is just a line, but we are going to translate, and then we're going to rotate about the origin. Okay, rotate, translate. Number 12, this is actually how you rotate not the origin. Basically, you're going to rotate about the origin, and then you're going to move the center point. That's how you rotate on another point, is you basically do a rotation, then a translation. Okay, rotation, reflection. So we're just going to do a bunch of the combinations, and that's basically the end of this chapter. Okay, and I'm going to do one of these, 11 through 16. You pick, and I will do to make sure you understand that, and that's the hardest problems, and then we'll just work. Okay, so look at the assignment, and I'll show you what the assignment is. And I'm going to drop things on the ground. So the assignment is going to be 176, 7 through 16. So you look and see which one you want me to do, and I'll just do that one to make sure you can understand. And I would suggest either something in between 11 and 16. And if you're not going to, I'm just going to color on the YouTube. I'm just going to start coloring my letters. I mean, some of you just would rather see me color, right? So which one do we want to do?
Can you do number 11?
Which one? Okay, 14 sounds good. That's better than coloring. Okay, some of these are good visually. Some of these are better just to do the points. I'll probably do both. That might be better. So I'm supposed to reflect first, and then I'm supposed to rotate. That sounds great. So the first thing I'm probably going to do is I'm going to graph the line, and probably we'll graph it in, sure, let's graph it in red, I guess. So my 2 points are -3, 1. That's X. And then I think I got 4, -5. So this is the original one. And we're just doing a line segment. And I like that because, well, it's definitely a lot less work to do a line segment than like an octagon, right? It's just 2 points. Okay, and I'm supposed to do what now? Reflect it. I'm going to draw the mirror because, well, I like to draw the mirror. So this is the mirror, y equals x. That means start on 0, up 1, right 1. And I'm just going to put little dots so I don't do it crooked. Down 1, left 1. So this is going to be interesting since they're both where they are. Okay, there's my mirror. And remember, it's tough to use this mirror, so I'm going to use the formulas to do this. And so the formula for the y equals x, I believe, is you just switch the order. Okay. So it's BA. AB equals BA. So I'm going to go ahead and write my different stuff here. And I'm going to try to color code it. I'm going to do it down here so I don't interrupt things. So x is -3, 1. Y is -3. It is not. That is lies. It is 4, -5. All right, x prime says switch the order, so it's just this. You can't see it all? It feels like you can, but I guess you can't. Thank you for saying that. So that was just what was written in the book. So the formula is to switch the order. That's how you reflect about y equals x. And this way I'll get it in the right place. Okay. And that's y prime. So I'm going to go ahead and get this graphed up. We'll move back to the graph. All right, so this says 1, 3, 1, negative 3. This is going to be x prime. And y is going to be negative 5, 4. This is going to be y prime. So I've now moved it. I've reflected it, right? And this is what I mean, like, the formula really helps me because it looks weird, but if you look at the individual points, these points look reflected, right? They look about the same distance away from my mirror. And these points look about the same difference. Okay, so I've reflected it. What do I do next? I rotate it 180 degrees. What is the formula for rotation? Do I keep it in the same order and just change the signs? If you say yes, that is correct. So x double prime, I'm going to keep it in the same order but change the signs. And you don't have to put a positive 3. It makes me feel better because I like to do that. Because that means I changed the sign. I added a line. Okay. Did I do that right? Let's find out. Let's go to the graph. And so negative 1, 3. This is x. And positive 5. Down 4. And here we go. And this is x double prime, and this is y double prime. Okay, let's see if this makes sense for the rotation. 180 degrees, right? Did I rotate 180 from this one? Because that wouldn't make sense. No, I rotated 180 from this one, right? So in theory, I could rotate the whole thing, and this one would take the place of this one. So if I did this, let's take a picture. Let's see if this will work. If it works, it'll be amazing. Probably won't because I don't think I have it centered. But it might be close. All right. So this is just a random guess that this will work. So in theory, my black line or my red line, my blue line, will be where the black line is. Let's see how close it is. Now my mouse doesn't work. Come on now. Just go over here, do what I say. There we go. Well, that's inconvenient. Why doesn't it do what it's supposed to do? Probably because I had to click on something. See? There we go. Well, yeah, it was close. Not close enough. It wasn't worth the trick. All right, but that's what it is. Okay, get done. And if you have some problems, I'll just look at it and try to help you out.